Together we will solve another question involving differentiation, a past paper question. So all the credit goes to Cambridge, and check my website explainingmaths.com to find all my free resources there nicely organized. So what does it say? It says the equation of a curve is y equals 2x plus 8 over x squared. And the first question is obtain expressions for the derivative and the second derivative. And then we have to find the coordinates of stationary points of the curve, and we have to determine the nature. Yeah, is it a maximum or a local minimum? And the third question is show that the normal to the curve at that particular point intersects the x-axis at that particular point. Okay, so three interesting questions. Let's start with the first one. And before I find any derivative, we'll get rid of that fraction and rewrite it as 8x to the power minus 2. Okay, there we go. So the first derivative, y prime equals 2 minus 16 x to the power minus 3. Okay, so the x disappears. 1 times 2 is 2, and minus 2 times 8, and then 1 less to the power minus 3. And perhaps you want to rewrite that in positive index form, so x to the power positive 3, like that. And then y double prime, the 2 will disappear, minus 16 times minus 3, what is that, 48. And then again, decrease the index by 1, so to the power minus 4. And maybe you want to rewrite that as 48x to the power 4. Fantastic. 3 points in the pocket. Let's continue. Find the coordinates of the stationary points and determine the nature. Now, what is the stationary point? Stationary point is where the gradient is 0. So even if you would say that, let me put I there, that was question I. Even if you would say, well, that means that y prime has to be 0, you get a point for that, yeah, where you say dy dx equals 0. So let's find out, when does that happen? 2 minus 16 over x to the power 3, the gradient function. You're going to find out where that is 0. I'm going to move that term with x to the other side, so it is positive now. I'm going to do some cross multiplication, so I wrote down 2 as 2 over 1. So I'm going to get 2x to the power 3 equals 16, x to the power 3 equals 8. So x, I'll just squeeze it in here, and I'll do it over there, x equals 8, so the cube root, which is 2. There you go. So we have one stationary point where x is 2, but they ask for the coordinates. Hang on a minute, not just the x, so also the y value. So how can I find the y value? Well, then I have to plug it in the original function to find the y value. So 2 times 2 is 4, plus 8 divided by 4. 8 divided by 4 is 2, so 4 plus 2 is 6. Y is 6. Let me just write it as a coordinate 2, 6. There you go. That's the coordinate, but we also have to determine the nature. Is it a minimum or a maximum? Well, then you have to look at the double derivative. So you plug in that value of x, which is 2, in the double derivative, and you look whether it's positive or negative. So 48 over 2 to the power 4, the double derivative or the second derivative. I'm only interested in the sign, and that is clearly going to be bigger than 0, positive. And therefore, whenever the second derivative for that value is positive, we're talking about a minimum. There we go. There are other ways of finding out the nature of the stationary point. This is what I always do. And I think most students do the same. Good. Then I'm going to draw a line here. It's getting quite stuffy again. It's a small page on my tablet, so I try to squeeze everything on it. I do apologize. What's going on? They say, show that the normal to the curve at that point intersects the x-axis at minus 10, 0. So we're going to find the equation, and I always write it down in gradient intercept form. I know there are other ways of doing it, but this is just what I'm used to, so I'm going to continue doing that. So first find the gradient of the normal. Well, the normal to the curve, let's find out what the gradient of the curve is at that particular point, because the normal is going to be the reciprocal opposite sign. Okay, so the gradient at the curve itself for x minus 2 is 2 minus 16 over minus 2 to the power of 3. And if you plug that in your calculator, you're going to get, what is that, 4. There you go, 18, 6, yeah, 4, that's correct. So the gradient of the curve is 4. That means the gradient of the normal line, I will continue in blue again, is going to be 1 over 4, well then the opposite sign, so minus 1 over 4 x plus c. There you go. So this is the equation of the normal line. I need to find the y-intercept, so I'm going to plug in the point. So y is minus 2 when x is minus 2 plus c. That is times, by the way, sorry. Minus a quarter times minus 2, that is going to be half. And then minus a half, so c is minus 2.5. Yeah, I'm doing a few steps in one because I do not have the space to write it all down. But c is going to be minus 2.5. All right. They're telling me I have to show that it intersects the x-axis at point minus 10, 0. Well, the x-intercept, that's when the y-coordinate is 0. So if I do the last step in black, I'm going to find out, well, when y is 0, what is the value of x going to be? There we go. So I'm going to move the 2.5 to the other side. So it says 2.5 equals minus 1 over 4x. And to isolate x, I'm going to divide both sides by minus 1 over 4, or if you like, multiply both sides by minus 4. And then x is going to be negative 10. There you go. And indeed, that's what they said. Show that the normal has an x-intercept of minus 10, 0. Good, I hope that was useful. Check my website, explainingmaths.com, for all my other free resources. And please like and share if it was useful, then I can help your friends too. I wish you a very pleasant day. Bye-bye.